heat can transfer through radiation by, like, let's think of a microwave. Radiation will transfer, okay, so the microwave will transfer electromagnetic waves, and then electromagnetic waves will travel through, let's say, your macaroni and cheese in your microwave, and that'll go straight through it and just warm it up, like, super fast. So basically what it does is it just sends electromagnetic waves through and cuts straight through it. Think of like a sword going through like a watermelon or something. It goes like that and it just heats it up.
Convection. So here's a little scenario to think about. You have a wood stove in a room. The cool air around it will then heat up and then make the molecules expand, making them less dense and float out. Then it cools down and reheats and just repeats itself.
Conduction. Like, the third thing with heat transfer is conduction. So let's say that you're making eggs for breakfast or something. You have your frying pan, you have your eggs in your frying pan. Put your frying pan on your stove, and since the stove is hot, the heat from your stove will just transfer into your pan, and that pan will heat up and just heat up all the way around it. That's why, like, when you pick it up, it's hot. So what it does is it'll just come from your stove into your frying pan and fry your eggs.
For the conclusion, there are three types of heat transfer. The first one was radiation that we talked about, and that is basically just electromagnetic waves that, like, when they hit an object, it would heat the object up. Then convection is when you have, when you have boiling water, the air particles in the boiling water will start moving around. And then you have conduction. Basically, conduction is when an object heats up and it makes direct contact with something. Let's say you have a burning, a pan on a stove, and someone touches the handle and it's and they make contact. That will burn their hand due to conduction and from heat transfer from the stove to the pan.
Okay. And now we have a convection video to show you guys. And it's everybody's favorite person in the world.
Who is it?
Bill Nye the Science Guy.
Oh, yeah.
Bill Nye the Science Guy. Mountains are icy, but they've got motion of molecules. Ha! See, even cold things have heat. Things like snow and icy mountain lakes and glaciers, they've got heat. Anything with molecules has heat. It's just that the molecules in cold things are moving more slowly than the molecules in warm things. Okay, y'all ready? Sing along. It doesn't matter whether something is cold or hot. If molecules are moving, keep something on the gun. You know the words now, sing along. It doesn't matter whether something feels cold or hot. Here's a question. Which has more heat energy? This hot burning match or this beautiful ice sculpture of science? Well, the match is hot, right? And sculpture's cold. Well, they're both made of molecules, right? But which has more molecules? The ice sculpture. A lot more molecules. So although they're much colder than the match, they actually have more heat energy. More molecules, more heat energy. Think of it this way. Suppose you tried to take a burning match and use it to melt the whole ice sculpture. Well, it's not going to happen, right? I mean, the match is going to run out of molecules long before the sculpture. So, more molecules, more heat energy. Oh, ow, ow. Careful. This one.
And that was convection.